GE. Content carried in here is suitable for general family viewing.
Good morning, learners and all the other viewers at home. At KU TV studio today is Teacher Mary. Teacher Mary will be taking you through a science lesson on sinking and floating, and the topic is the properties of matter. Welcome. Properties of matter is what we are going to look at. And we find that matter, we usually say that matter is anything that has weight and occupies space. Matter is anything that has weight and occupies space. Now we have three states of matter. And the three states of matter are solids, liquids, and gases. Now, as we talk about the topic floating and sinking, we are going to consider the three states of matter as we investigate the various aspects of floating and sinking. So, our topic from the topic properties of matter is floating and sinking. Floating and sinking is our topic for today. So we start by asking ourselves what is floating. Many other times that you have put something in a liquid and it comes to the top of the liquid. So, in regard to floating, we'll look at which solids. So, here we are looking at solids and liquids. We are also going to look at how the gas affects floating and sinking. So, we are going to look at solids and liquids. It is the solids that usually float in liquids. So in this case, we say that floating is the ability of an object. In this case, the object here is a solid, is seen on top of a liquid. There are many things that make solids to be seen on top of a liquid, and the opposite happens to sinking. So, sinking is the ability of a solid to be fouled or to go down to the bottom of a liquid. So, we look at sinking as the ability of a solid to be found at the bottom or down a liquid when you put it in a certain liquid which is in a container. The ability of an object. The object in this case is a solid. to go down a liquid. Or be found at the bottom. To be found at the bottom of a liquid, and this liquid is in a container. Now we have said there are many aspects that we investigate when we are discussing floating and sinking. So if we look at floating, we are investigating floating. There are many solids or objects that can float. For example, we have feathers, we have paper, we have objects made of plastic, we have objects made of wood, we have objects made of wax, feathers, paper, plastic, wood, and wax. All these items usually float, and they are called floaters. If we look at sinking, we have objects that sink. Such objects can be made from metals. All objects which are made from metals usually sink when you put them in a liquid, or they go to the bottom of that liquid. Now we have stones. When you put stones in a liquid, they will go to the bottom, so that is sinking. We have items like chalk. When you put pieces of chalk in a container where you have a liquid, they will sink. So those are just examples of items that sink, and they are called sinkers. So we have examples of items that float and items that sink. The items that float are called floaters, and the items that sink are called sinkers. Now, it's very important we look at this topic because it will help us in our daily lives. For example, when somebody drowns and you hold on to a log of wood, wood is a material that floats. However big that piece of wood is, it will always float. So that person will not sink because the floater wood will make this person to float on top of the water. Now, we have factors to investigate in floating and sinking, and that is our next item that we are going to look at. We are going to look at factors that affect floating and sinking. Factors that affect floating and sinking is what we are going to look at. We have three factors that affect floating and sinking. Now we have three aspects that we usually investigate. In our experiments on this topic, we investigate three aspects, and these aspects are material, we have shape, and we have size. These are the aspects which are investigated, and you can do some of these simple experiments at home as we move on. So we investigate these three aspects, and we are going to see how they affect floating and sinking. Now we start with material. let's take an example of, maybe plastic. You can take items made of plastic. You compare small items and big items, some which are heavier than others. You can take a plastic cup and you can take a plastic bucket. Now these are not of the same size, they are of different sizes, they have different weights, but when you put both of them in water, they will always float regardless of their sizes, regardless of their weights. So you find that one of the aspects which is investigated in floating and sinking is plastic. So you find that all materials made of plastic will float. All materials which are made of paper, will float. All materials which are made of wood will float. All materials which are made of wax will float. You can take a piece of wood, a small piece of wood, like a pencil or any other item you have at home, and put it in a basin of water. And you can take a big piece of wood, even a stool made of wood. If you put both of them in water, they are of different sizes, but they will float because of their material. So the next thing that we are going to look at is shape of objects. In this case, we are going to look at a piece of an item which is made of metal. We may take sufuria. A sufuria is made of metal. Now, if you take a sufuria is made of metal, and it may be heavy. It is made of metal and it is heavy. If you put it on water, the sufuria will float because of its shape. It has a hollow part. This hollow part traps a lot of air. The surface area still will also make it to float. If you crush the same sufuria, or you make it maybe into a ball, you crush it like that. So you make it into a ball and you put it in water, it will sink. If you have a bottle top, you can take a bottle top there at home. You can look for a bottle top. It is made of metal, and metals are sinkers. If you take this same bottle top and you put it on water, the bottle top will a bottle top is made of metal, and metals are sinkers. But because of the shape of a bottle top, maybe that shape, if you put it in water, it will float, although metals are sinkers. If you crush these same bottle tops and you make it something like a ball, you change the shape of this bottle top. So you find that because you have changed the shape, it will sink. That means that this one floated because of its shape. This shape will make it to float on water. So shape affects floating and sinking. You find that you can have items which are made of sinkers, but when you change their shape, they will always float. Now, you also find that we have other items apart from the bottle top, which you can change, which you can investigate at home very easily. We also have other items like or other things that shows that as that shape affects floating and sinking. A boat, the shape of a boat, the shape of a ship is very heavy, a boat is very heavy, and that is size. Now, size is usually investigated, but you find that these two, the material and the shape, are the only ones that will affect floating and sinking. If you look at a ship, it's very big and it's very heavy, but does not sink regardless of its size. We have looked at a sufuria here, a smaller one, a bigger one. So long as it has this shape, it will always float. We have also given examples of a log of wood and a small piece of wood, or a small item made of wood like a pencil. If you put them in water, regardless of their size, they will float. Now, so size does not affect floating and sinking. So we have learned that the three aspects which are investigated in floating and sinking, only two of them affect floating and sinking, and that is the material and the shape. This one, the size, does not affect floating and sinking. So in your questions, as you revise the topic floating and sinking, you should always remember that aspects that affect floating and sinking are three. We have material, we have shape, and we have size, but only the material and the shape that affects floating and sinking. So I would like us to look at some questions which are usually asked during the KCPE. So these are the KCPE questions. You can find them from past papers. You can look for KCPE boosters and find these questions and do them. So 2017, number 11 and number 33, 2014, number 36, 2013, number 39, 2012, number 21, 2011, number 36, 2010, number 11, 2009, number 37, 2008, number 12, 2007, number 28, 2005, number 40, 2004, number 17, 2002, number 23, and 2000, number 10. So you can see that this is a highly tested topic, and you should look at those questions that we are going to look at a few. So we are going to look at 2017 number, we are going to look at 2017 we start with 2017 number 11. 2017 number 11. So I'll write the question here, the table below. The table below shows the results. Of an investigation done by pupils on floating and sinking. So I am drawing that table here. So we have student and we have objects that sink and we have objects that float. We have the choices: charcoal and pencil, and we have a pin and a razor blade. Then have F, recorded a bottle top and a stone. Then we have a metal dish and a plastic plate. Then we have student G, a nail and a piece of glass. Then here we have candle wax and plastic bag, and we have student H. This is wood and wax. Here we have a nail and a stone. These are students who recorded objects that can sink and objects that can float. Now they gave their, we are going to look at the answers. Student E said charcoal can sink and a pencil can sink. Now this is wrong because charcoal is made of wood and wood is a floater. The same case applies to a pencil. A pencil is made of wood and wood is a floater. So this is wrong. Then we move to objects that can float. A pin. A pin is made of metal, so it is a sinker. A razor blade is made of metal, so it is a sinker, depending on the way you place it on the liquid. Now we have bottle tops. A bottle top usually floats, so it is wrong in this column. Then we have a stone. A stone can sink. Then we have a metal dish. A metal dish, because of its shape, it can float. Now we have a plastic plate. This is a floater because of the material. Plastics usually float. So F is wrong because of this, because of the bottle top is not a sinker. Now we move to G. A nail can sink because of its material. It is made of metal. A piece of glass is a sinker because all glasses, whether big or small, whether a rod of glass or a glass, can usually sink, so it is a sinker, so it is in the correct column. Then we move to candle wax. Candle wax is a floater. because of the material, this material wax usually floats, whether it is big or small. Then we have plastic bag, it floats because of the material. So that question, we move on to H. Now wood is a floater regardless of its size or weight, so it is in the wrong column. Then we move to wax, it is also in the wrong column because of the material. Then we move to floaters. A nail is a sinker, so it is in the wrong column. Then even a stone is a sinker, so it is the wrong column. So you find that the student who recorded the correct observation is student G, because these two, the nail and the piece of glass, are sinkers, while cardboard wax and plastic bag are floaters. We can move on to another question. We move to another question. And the question that we'll look at is 2014, number 36. 2014, I write the question on the board. In an investigation on factors affecting floating and sinking, in an investigation on fact carried out the following activities. Activity 1, placed a bottle top. They placed a bottle top in water. Activity 2, they made the same bottle top. They made the same bottle top into a ball. And placed it on water. The question was, which one of the following factors were the pupils investigating? Now there are choices given, but even before we move to the choices, they placed a bottle top in water. That is a fact activity that they did. Now, of course, you should ask yourself what happened when they placed this bottle top on water. Remember the shape of the bottle top. Although it is made of metal, it will make it to float, although metals are sinkers. Now, they made the same bottle top into a ball and placed it on water. Now, let us look at the choices given. A, size. A, size. B, shape. Type of material. And the last choice, mass. Now, the fact that metals sink may confuse a learner, but remember that although a bottle top is made of metal, the shape that a bottle top has will make it to float. Now, when you crush it and make it into a ball or change it into a ball, you have now changed the shape. So it is not the material because metals sink. So that one is out. Mass, it is not mass because mass is not in the syllabus as we investigate floating and sinking. It's not because of the mass, because even heavy objects, whether they are some heavy object may not float, and therefore it is not mass. So the size of this bottle top, the size has not changed. Big objects can float because of their materials. So we find that since you have made this metallic bottle top into the shape it has, it will float, and therefore when you crush it again, you find that you have now changed the shape and it is going to sink. So the correct answer is choice boy. Now we look at another question. And the question that we are going to look at is 2013, number 39. We are going to look at question 39 of the year 2013. Number 39. The question is here: which of the following groups of objects consists of only objects that would sink in water? Choice A, piece of chalk, steel needle, and stone. That is choice A. Nail, piece of glass, and stone. Correction there. This is cork. Bottle top, nail, cork, and dog, piece of chalk. And plastic bottle. Okay, so we look at the materials. You have to read the question very carefully because you may get confused. That is, there are some key words like only and sink. So you're looking at a group. Remember, in each choice, all of them must be sinkers. So in choice A, we have a piece of chalk. This one is a sinker. We have a steel needle. This one is also a sinker. Now this is because of the material. Chalk will always sink. Steel needle, steel is metal, so it will sink. And then we have cork. Cork is a material that floats. Now we have, so this one makes choice A out. Choice boy, we have nail. This one is a sinker because it is made of iron. It can also be made of steel. It's not specific, but a nail is made of metal. A piece of glass. Now glass usually sink, and we have a stone. All stones will sink. So before we conclude that that is our correct answer, we have to move on to the other choices, like a bottle top. This one is a floater, so it is out. We have a nail. A nail will sink. Then we have cork. A cork will float. So this one is out because a bottle top and a cork will float, and we are looking at sinkers. Then we have a piece of chalk. Here, a piece of chalk will sink, so it is correct there. Then we have a plastic bottle. Plastics are floaters, so a plastic bottle will float. So this one makes choice dog wrong, and so our correct choice is choice boy. So you have to be very keen. You have to be very careful. You have to read the question carefully and read it many times so that you understand what you are being asked. Then we can have another example of a question on floating and sinking. Then we can have 2012, number 36 of the year 2012. Let me write it here. No, I don't really have that question. So we can take another one. We can take question 209, number 37. So we have done that one. That one. We move to 2009, number 37, and the question reads, which of the following activities, and I would like you to note that in all the questions on floating and sinking, we have activities being carried out because the subtopic of the topic floating and sinking was investigating factors that affect floating and sinking. That is why you find that in most of the questions on floating and sinking, we have activities to be carried out. So the question number 37 of the year 2009 reads, which of the following activities will make aluminium remember, aluminium is a metal. So anytime we are reading a question on floating and sinking, you should ask yourself various questions. The key words, so aluminium foil that was floating on water to sink. A, increasing amount of water, increasing the amount of water. B, rolling the aluminium foil into a tube. C, making holes on the aluminium foil. and D, crushing the aluminium foil into a ball. We look at each one of them. So increasing the amount of water. So before you look at the choices, read the question carefully and note the keywords. Like, this is an aluminium foil, and we have it was floating and you want it to sink. So the aluminium foil, aluminium is a metal, and metals are sinkers, but this one is a foil. It is like a sheet of paper, so when you place it on water, it will float because of its shape. So the aluminium foil, regardless of being a metal, will float because of the shape it has. Now, when you take this foil and you put it on water, it will float. But the question asks, how do you make this aluminium foil to sink? The first answer is increasing the amount of water. You should ask yourself whether when you increase the amount of water, you'll change the shape or the material, and your answer will be no. So it will not affect, it will remain floating, it will not affect this aluminium foil. Then rolling the aluminium foil into a tube. When you roll it into a tube, it will remain afloat, it will still float. Then we have making holes on the aluminium foil. Making the holes on the aluminium foil will not change its shape. So you can only make it sink if you change the shape. And so when you crush the aluminium foil into a ball, you have changed the shape of this aluminium foil. And so our correct choice there is choice dog. Then we can have another question. We can have another question on floating and sinking. Now, revising these questions will help you to prepare for your exam, because you find that in most cases, questions are repeated or no, although not copyrights. So we can take another question like 2010, number 11. And I write it here. Which one of the following pairs which one of the following pairs consists of only materials that would sink, that would not sink? In water, even when the shape is changed. So, which one of the following pairs consists of only materials that would not sink in water, even when their shape is changed? Okay, so here you read the question carefully and underline the keywords. You are looking at pairs. You are looking at pairs in the choices that would consist of materials that would not sink even when the shape is changed. So The first pair is wax and wood. The second pair is wood and aluminium. The third pair is aluminium and glass, and dog is glass and wax. If you look at the choices given, you find that aluminium and glass are usually repeated here. Now this is very confusing because in most cases you find that most of the things that we have at home which are made of aluminium are sufurias, and when you put sufurias in water they usually float. But remember, we also have other objects which are made of aluminium. So the same case applies to glass. Because of its shape, the glass that we usually use at home, maybe for drinking water or any other thing, is usually has a hollow shape, and this may confuse the learners because they think the hollow shape will make it to float, and yet we also have other objects which are made of glass and they sink because glass is a material that sinks. It is a sinker. So we look at the choices. We are looking at pairs where both, we are looking at choices where both the objects will not sink. That means they will float. Not sinking means that the objects are floaters. So we have choice A, which is wax. Wax is a floater. And we look at wood. Wood is also a floater. Then we don't stop there because this is how some learners end up wronging an answer because of not looking at the other choices when you find that the correct answer is either A or B. Okay, so we move on. We look at choice boy. We have wood. Wood is a floater, but aluminium is a sinker. So that pair is wrong. So we have aluminium here. Aluminium is a sinker. So the ticks mean that the material there is a floater. So we look at glass. Glass is a sinker too. Then we move to dog. Glass is a sinker, and we have wax, which is a floater. So the only choice that has both materials being floaters is A, and that is our correct answer. So we can still have another question. These questions will help us a lot in determining the aspect which is being investigated. Among the three aspects that we have when investigating floating and sinking, or aspects that affect floating and sinking. And remember, we said that the two aspects that affect floating and sinking are shape and material. Size is investigated just to make sure that it is only material and shape that affects floating and sinking, but the size of an object does not affect floating and sinking. The next question that we can have is 2007, number 28. Now I'm writing the question. This one is a sufuria, and you can note that a sufuria in this case, in this topic of floating and sinking, appears in very many questions. A sufuria made of steel, a sufuria made of steel weighing 100 grams floats on water, while a nail weighing 50 grams sinks. This is because of the difference in the choices are type of material, the second one volume and shape and mass. Now, if we read the question, a sufuria made of steel, you underline the keywords. It is a sufuria, it is a keyword there. It is made of steel and it is weighing 100 grams. And what does it do? It floats on water, while a nail weighing 50 grams will sink. Now, these items, the sufuria and the nail, are both made of metals. The sufuria is made of steel. You find that this word steel here is a key word. We know that most of the sufurias that we have are made of aluminium, and if a learner is used to that sufurias made of aluminium are the ones that will float, he or she may get confused that steel is heavy. It is one of the heaviest metals, and so thinks that it will sink. But the actual thing is that the sufuria, because of its shape, will always float. And then we have a nail, which is a nail can either be made of steel or iron, but because of the material and also the shape of the nail, a nail will always sink. Now, the question is, why does this sufuria float and why does the nail sink? Now, type of material. Now, both the sufuria and the nail, as you have seen, are made of metals. So this is not the reason why the nail will sink and the sufuria will float. It's not because of their volume, because volume is not in the syllabus as we investigate floating and sinking. At the same time, it does not affect floating and sinking. As we have seen earlier, volume does not affect floating and sinking. So it is also a wrong one. Now it is, we have shape, and we have said that shape is one of the things that affect floating and sinking. And these two, the sufuria and the nail, both of them are made of metals, but the sufuria will float because of its shape. So we take a shape, we put a tick there, and then we said we should not stop there, we should move to dog. Now D, mass, we have mass. Mass does not affect floating and sinking of an object. It is only the shape and the material that affects floating and sinking. So you find that in most of the questions that are asked in KCPE on floating and sinking, you have to consider shape and the material. Now, and you have to remember, even mass comes in the choices, but does not affect floating and sinking. The same case applies to density. It does not affect floating and sinking in this case as taught in the primary syllabus. So we move on. We can still have another question, and we can have 2004, number 17. Let us see what is being investigated there and or what is being tested in that question. 2004, number 17. I'm leaving some of the questions because they are kind of repeated and testing the same aspect. So we move on to 2004, number 17. The question reads, a 1 long meter ruler, a 1 meter a 1 meter piece of wood, not a ruler, it is a piece of wood. A 1 meter long piece of wood floats on water, while a 1 centimeter long piece of iron rod sinks. This is because of the difference in, now you have the choices. A, length. B, weight. Choice boy is not choice B. Material and C, weight. And this is shape. Okay, so we have our question is on a 1 meter long centimeter, a 1 meter long piece of wood. So the keywords here are wood and 1 meter, because it will give us a difference in the sizes. So 1 meter and a piece of wood is a keyword. It floats. And then a 1 centimeter long piece of iron, the material here is iron, will sink. The iron rod sinks. So 1 meter long piece of wood, it is longer than the piece of iron, the 1 centimeter piece of iron, and yet the piece of iron will sink. Why does it sink? Now, is it because of the length? No, because it is even shorter than the piece of wood. Is it because of the material? Now, the material is one of the things that affect floating and sinking. You should always remember that. So, the pieces of wood or wood will always float regardless of its size or even its weight. So we put a tick there as we move on and find out whether there is another answer which is close. Now we look at weight. Weight does not affect floating and sinking, so it is out. Then we look at the shape. We are not given their shapes here, and regardless of their shapes, wood will always float, while iron will always sink unless the shape has been changed. So here it is not because of this shape, because we are told that it is an iron rod. So the iron rod will not float, it will sink. So here the correct answer is choice boy. Because of their difference in materials, that is why the piece of wood will sink, the piece of wood will float, while the iron rod will sink. So I think we are done with our lesson for today, and it's a very important topic because it's usually tested, and you can revise you can do those simple experiments at home. You can take different materials and put them in liquids. You can even take sugar. When you put sugar in the tea, the sugar will settle at the bottom because of its material. So unless you stir it, you will find it at the bottom if you don't stir. So do those simple experiments at home. Take different materials of different shapes and put them in water. Take also materials of different sizes and put them in water and find out whether they will sink or they will float. So you should, when you're answering questions on floating and sinking, you should always remember that it is only two aspects that will affect the floating and sinking, and that is material and shape. Size does not affect the floating and sinking. Although it is one of the things that is investigated, it does not affect floating and sinking. So if you have any question, you can send your question to the number on the screen and we'll take care of it. So until next time, it's goodbye for today. Thank you.
Na leo tutakuwa tunafanya maandalizi ya samaki wa baharini kutoka Buffalo Villa ambayo inapatikana Malindi.
Leo niko hapa Buffalo, nataka kumtayarishia samaki wa kukaanga. Tunamsaumu, tunampaka fresh. Sasa ukiweka ule samaki, unasubiri tu muda kidogo. Kwa samaki si mgumu hata kwa yuko soft.
Good morning, everyone, and especially our students, wherever you're watching us from. This is KUTV Elimu Live. Welcome to our another lesson for mathematics. Today we are revising a Form 3 topic, further logarithms. And before we revise or we look at what is in further logarithms, this topic is a build-up of a topic in Form 2 we call indices and logarithms. And so it then means that you have to get the message that is in indices and logarithms before you can now handle further logarithms. So you'll find most of the information we are going to share in this topic today will actually be based on what you learned in Form 2 under indices and logarithms. So I welcome you to our lesson on further logarithms. And at the end of it all, there is only one main thing that we need to understand in the topic further logarithm, and that is the application of the laws of logarithms to solving and simplifying logarithmic equations and expressions. So we are going to deal with two things. We are going to look at logarithmic equations, and number two, we look at logarithmic expressions. And so when you have these two, for logarithmic equations, we are going to solve. So this will be solving of logarithmic equations. And number two, in expressions, we are going to be simplifying. So we simplify logarithmic expressions and solve logarithmic equations. The two will be based on understanding of what we call the laws of logarithms, the laws of logarithms. So in short, in our lesson today, we want to see how we apply the laws of logarithms to one, solution of logarithmic equations, and number two, simplifying logarithmic expressions. But even before we break it down, I want us to build from the Form 2 topic and remind you something, that in Form 2, if we can make our recall, number one, you looked at what we call laws of indices, the laws of indices, because this is where we start from. And we looked at three basic laws of indices. We have three basic laws of indices. We have the multiplication law, and the multiplication law states that we have a number a raised to the power m multiplied by a number a raised to the power n gives us a, we add m plus n. That is the multiplication law. And you will realize that we're talking about indices. Indices are simply powers of numbers. So in this case, m is an index, n is an index, and so m and n are what we are calling indices. A in this case is the base upon which we are writing the powers m and n. Number two, we have what we call division law. And we have a power m divided by a power n gives us a, m, then we subtract n. Then number three, we have what we call the power of power law. Where we have a number a raised to the power m raised to the power n. Now we have two powers. So in this case, we multiply the two powers and have a case of a power m n. These are the basic laws of indices. However, we have the laws by extension, which we call the principles. And so that starts from now, number D. In D, now this is a principle. We have what we call the fractional law, the fractional index law. When dealing with fractions, for example, we have a number a raised to the power m over n, raised to the power m over n. In fractional index law, we separate the numerator and the denominator. And so we end up having a power 1 over n, then we raise to the power m. So we read this as the nth root of a mth. The nth root of a mth. What first get is the nth root, then we raise to the power m. Practically, this could be a case for this example. If we have 27 raised to power 2 over 3. What I mean by fractional law, you simply split the numerator and denominator, so you have 27, now raised to 1 over 3, then we raise to power 2. And so in this case, when we talk of the nth root now, it's the cube root of 27, which is the cube root of 27, which is 3. Then mth is now squared. So we square this one, and so the solution becomes 9. This is called the fractional index law, which is an extension of the three laws. We have another one we call the negative index law. Negative index law. In the negative index law, we have a number a raised to the power of negative n. Now, what we have in this case, we take the reciprocal of the number given to now a positive power. So we'll have 1 over a power n. The reciprocal here means simply 1 over the number. So when you have this, we have, for example, we can have a case like 2 power negative 4. It implies 1 over 2 now to the positive power 4. And so we end up having 1 over 16. So that is called the negative index law. And finally, a principle, number 6, what we call the zero index law. You should be knowing at this point that any number times 0 is 0. Any number, irrespective of how much it is, multiplied by 0 gives you 0. And so in the zero index law, we have a number now raised to 0. This does not mean a times 0. It means a power 0. And so zero index law, any number power 0 is 1. Any number power 0 is 1. So that is what we call the laws and the principles of indices that we looked at in Form 2 under indices and logarithms. Number 2, we need to review again something we call the two forms of writing indices. We have what we call the index notation. When you have a number, that is a power n is equals to c, then this is referred to as what we call the index form. This is the index form or index notation of the number a power n. We can change this now to introduce logarithms. And so we end up with what we call logarithmic notation. Logarithmic notation. In logarithmic notation, now we introduce the log, in this case, used to represent logarithm. It is of the number, so we put the number c, and retain the same base a, and now the power becomes the solution of the log. In short, when you have 2, power 3 is always equals to 8. This form is called the index form. The index form or the index notation. We can change this to logarithmic notation by introducing logarithm. So we write logarithm of what's the number? 8 to the base 2 will be 3. So this form of writing numbers is called logarithmic notation. Therefore, students, understand that we have two forms of writing numbers here. We have the index form, and then number 2, we have the logarithmic form. In index form, we use the powers. In logarithmic form, we introduce the logarithms. And that is where logarithms now starts, dealing with logarithms rather than the indices. Number 3, I want you also to remember something about logarithms. We have what we call the laws of logarithms. With the laws of logarithms. And these laws of logarithms, as you will realize, they are formed or they are generated from the application of the laws of indices. So in this case, what we do, we have the law number 1. When you have the log of a number, let's say a times b. This a, b to the base n. Then I will have this as log of the number a to the base n plus log of the number b to the base n. That is the first law that is coming out of the multiplication law in indices. Number 2, the log of a number a over b to the base n will give us the log of a number a to the base a less the log of a number b to the base n. Again, from the division law of indices. And number 3, log of a number a to the base n. Now, this is to the power m. I will then obtain m log of a number a to the base n. Again, from the power law in indices. you realize one thing, that what is happening here is that we are getting the loss from the loss of indices. So logarithms actually are generated from the loss of indices, and that is why we've looked at the index and logarithmic notation, which are given together. Now, we don't have any fractional law in logarithms. We don't have the negative law in logarithms, but the zero index law then gives us a principle. We have a principle that we have in logarithms. So we have the logarithm of a number, logarithm of a number a to the base a. When you have the log of a number to the same base, it gives us 1. But here, we talk of a power 0 is 1. In this case, for us to obtain 1, we must have the log of a number to the same base. Then we'll obtain a solution of 1. So these are the laws that we want to use in our lesson to be able to solve and simplify logarithmic equations and expressions. I hope by that we are clear now. And so we will take review of the past cases equations in this topic and see how this concept has been tested previously. And you will realize one thing, that this is a common area in testing for paper 2. And so if you prepare it well, then you'll be able to collect the 3 marks with ease. Now we'll start with the first, that is in 1992. In 1992, unfortunately some of you are not there. In 1992, we were to solve for x. Solve for x. We were to solve for x in log 11 over 2, log 11 over 2 plus 2 log 4 over 11, and then we minus log 5 over 11 is equals to 2 log 4, 2 log 4, and then we minus log x. This is 5 over 2. 5 over 2. So what we now need to understand is that when dealing with logarithms, it is important to realize or to recognize, to acknowledge which is the base that we are using. If the base in the logarithm is not stated, then we always presume that the base is 10, because that is the common base in logarithm. So in this case, this question has not given us the base. And so it definitely means that all these logarithms are to base 10. So what we need to solve is to consider that the bases are the same, which is true. So we start by this case, say log of 11 over 2, we add. Now we apply the third law of logarithm in the second term. So we'll take 2 to the other side. So it becomes now log 4 over 11 now squared minus log 5 over 22 is equals to, again, the third law of logarithm. 2 becomes the power of 4. So we have log of 4 squared minus log x. Minus log x. So we work out this, we have log 11 over 2 plus, we square this on, so we shall have log 16 over 121. We minus log 5 over 22 should be equal to, now we square this on to have log 16 minus log x. Hope you are together. Step 2, we now apply the laws. Remember, we have addition at this point, so we will get to the law number 1. And so it will have log, now instead of the addition, we will have 11 over 2, we multiply by 16 over 121. And then, at this point we have minus, so we'll apply the third law, the second law, When there is negative now, that gives us division. So when we divide by 5 over 22, it simply means you multiply by the reciprocal 22 over 5. So this becomes one term. And then we equate it to log. At this point, we have 16 minus log x. So that becomes 16 over x. 16 over x. So we simplify this. This is 1, this is 11, this is 1, this is 2, this is 1, this is 1. And so we have log 16 over 5 equal to log 16 over x. The last stage here now, we have, remember this is log to base 10, log to base 10. We drop the logarithms, but we don't cancel. So do not cancel the logs. Simply drop the logarithms. Drop the logs, so do not cancel them. So if we drop, we shall have 16 over 5 equal to 16 over x. Then we do the cross multiplication. So we'll have 16x is equals to 80 over 16 over 16. And so the value for x is 5. The value of x is 5. So that is how you were to work out that question had you been a student in 1992 to have the 3 marks. Good. In the following year, in 1993, again this concept was tested, but now it was tested in this form. And they added 1 more mark instead of 3. They now gave 4 marks. That is 1993. You are told to solve for x. Solve for x. And then you have 2 log x base 10. And now this time they specified the base. 10 is equals to 1 plus 2 log 4 base 10. 1993, that was the case that was given. We have log x is, we find log x, and then we have 2 log x base 10 plus 5 log, that is log 5 base 10 is equals to 1 plus 2 log 4 base 10. Again, students, we apply the laws of logarithms as we've stated here. And in the first term, we start with the third law of logarithm. So we'll have this solution. The power becomes, 2 becomes the power of x. So we have log x squared base 10 plus log 5 base 10. Now we have 1. 1 has to also be written in log form. And that is now the principle that we've given, that the log of a number a to the base a is 1. So because we've already known the base is 10, then to get 1, we simply have to write log 10 base 10, because that will give us 1. Then plus 2 becomes again the power of 4, so we have log 16 base 10. Step number 2, we apply the law number 1. Because of addition, so we'll get up to multiplication. So we'll have logarithm of x squared by 5, that's 5x squared, base 10. Again, at this point, we have log 10 by 16, that is 160 base 10. Then what do you do next? We drop the logs. We drop the logs. If we drop the logs, we will have plus the bases. We drop the log plus the base. So we have 5x squared is equals to 160. Then we divide by 5, divide by 5. We get x squared is equals to, this is 1, this is 3, 32. X squared is equals to 32. So we need to solve for x. And so we'll find the square root on both sides. X becomes the square root of 32. Square root of 32 is the same as 16 by 2 for those who've done indices, SADs. So let's have x becomes 16 by 2, and so our x is that is 4 root 2. For those who've done SADs, for those who've not done SADs, you simply find the square root of 32. That should give us 5.837. That is 5.6. That's 5.67, not 8, but 5.6. That is the square root of 32. So you can either give it to that, or you give it in SAD form as your solution. So for those who sat for the exam in 1993, that was 4 marks. Very simple, just applying the laws of logarithms. The following year, in 1994, again, the concept was still tested. This topic was again tested. So in 1994, and it was made a bit now different. We have log 2x minus 11, 2x minus 11, minus log 2 minus log 2 is equals to log 3 minus log x. That is now what was captured in 1994. Log 2x minus 11 minus log 2 is equals to log 3 minus log x. Again, the same way 1992 was. They have not given you the logs. And so it tells you, we've already discussed that if the base are not given, then we presume that these are to base 10 because that's the common base. And so we work out this putting in mind that they are all to base 10. So we start at this point here. Because of subtraction, we go to the law number 2. And so we shall have log 2x minus 11 over 2 minus 2. We have log 2x minus 11 over 2 should be equal to log. Again, the other side we have subtraction, so we have 3 over x. We have 3 over x. We drop the logs. We drop the logs, and so we'll have 2x minus 11 over 2 is equals to 3 over x. Do the cross multiplication, and so we'll obtain 2, that is 2x minus 11 into x equal to 6. This gives us 2x squared minus 11x minus 6 is equals to 0. Minus 6 is equals to 0. And that is a quadratic equation. So we need to apply quadratics. And there are different methods of solving quadratic equations. I presume that we all know. We have the methods. We have what we call factorization. Factorization method. You can use quadratic formula. Quadratic formula. Or you may use what we call completing the square method. Completing the square method. These are the methods apart from the use of graphs that we use or we employ when we are solving quadratic equations. So let's work out using factorization, which is easier for this case. Product of A and C, that is negative 12. So two numbers whose product is negative 12 and the sum is negative 11. That should be negative 12 and 1. So we'll have 2x squared minus 12x plus x minus 6 is equals to 0. 2 is common, so we have 2x into x less 6. We add 1 into x less 6 and then equate to 0. So the two brackets are equal, then we have x less 6, 2x add 1 equal to 0, and work out separately. So we'll have x less 6 is equals to 0, implying that x is 6, or then we have 2x add 1 should be equal to 0, so we'll have x is equals to negative half. So those are two solutions or two values for x in our case. And that year, that question was 4 marks. So if you are following, then you should be able to know the range of marks that you will collect in this topic, which is tested almost every year. But I will show you a trend that will happen as we go by. In 1995, the case was made a bit different again. This is what happened. 1995. Now you are told to, without using logarithm tables, find the value of x in log x cubed plus log 5x equal to 5 log 2 less log 2 over 5. And this is different because in this year, you've been warned of using the logarithm tables, so that you go to the mathematical table to check for the values of log 2 over 5, but rather you apply the laws of logarithms that we've looked at. So there's nothing strange here. Now that we've done 3 years, there's nothing strange. In the first case, we apply the first law because that is addition. And the bases, again, they have not been stated. So the presumption that the base is 10 still holds. So we'll have, in this case, log. Now we have x cubed and then 5x. That will give us 5x power 4 is equals to, the 5 comes to be the power of 2. So we have log 2 power 5, that is 32. Then we minus log 2 over 5. Then we replace this with the law number 2. So log 5x power 4 is log 32. Now when we divide by 2 over 5, it means we multiply by the reciprocal times 5 over 2. And so this gives us log 5x power 4. This is 16, and that this is to be log 80. Log 80. We drop the logs again. We drop the logs. When you drop the logs, we have 5x power 4 is equals to 80. We divide by 5, then x power 4 should be equal to 16. So we find the fourth root of 16. X becomes the fourth root of 16, which should be 2. So the value of x is 2. Again, in that year, that question was 3 marks. So in 1995, you should have scored 3 had you been a candidate that year. Now, at 1995, we now missed to see the question in 1996. We missed to see the question in 1997, and now found it again in 1998. And when it's coming 1998, they are now bringing it differently, knowing that you've now revised the previous years, and so you are much comfortable to handle further logarithms. They brought 1998 as follows. The question was, you find the value of x. You find x if negative 3 log 5, negative 3 log 5 plus log x squared plus log x squared is equals to log 1 over 125. The only change here is the negative. That is perhaps the difference that is going to be in our case, the negative sign. But now that we've looked at all the laws, it is easier because we apply the third law. This becomes the power of 5. So we have log 5 power negative 3 plus log x squared is equals to log 1 over 125. This takes us to indices. Remember, we've looked at the negative index law. When you have number power negative, then it becomes the number power now, the reciprocal of the positive power. So now it becomes power 5, power 3, then plus log x squared is equals to log 1 over 125. We apply the law number 1 of logarithm, multiplication here. So we have log, this is now x squared, 5 cubed, that is 125, equal to log 1 over 125. Then we drop the logs. When we drop the logs, we end up having x squared over 125 is equals to 1 over 125. And so it means, therefore, x squared is equals to 1. X squared is equals to 1. Because 125 will cancel out. So to get x, that is the square root of 1. And so we shall have plus or minus 1 as our solution for x. So that is the solution in 1998 to give you 4 marks. As short as it is, 4 marks. That is how easy mathematics is. And so we now move to 2000. So again, we miss, in 1999, we missed the question, and we find the topic tested again in 2000. And when we get to 2000, it has been made simpler. And 2000, perhaps that is now the age of most of our candidates. And so then we are now living in your era. As we revise from 2000, that is now your era. And so we find the value of x. We find the value of x. You find x. And you are given log x plus 5. Log x plus 5 is equals to log 4 minus log x plus 2. Log 4 minus log x plus 2. Now with the same procedure, I hope now some of you have started working out and you should be getting the answer even as we explain. We apply the second law on the right hand side of the equation where there is subtraction, so that we obtain this solution. Log x plus 5 equal to, we've log now 4 over x plus 2. X plus 2. I will drop the logs. And so I'll have x plus 5 equal to 4 over x plus 2. So we do the cross multiplication. We have x plus 5 times x plus 2 is equals to 4. This is expansion. You expand this quadratic, so you expand, we shall have x squared plus 7x plus 10 is equals to 4. X squared plus 7x plus 10 is equals to 4. Oh, someone should be wondering how. We've multiplied x by x, that is x squared, x by 2, that is 2x, then 5 by x, 5x, 5 by 2, that is 10. So we have 5x, then we have 2x. 5x plus 2x, that is 7x. That's why we have that quadratic equation. We bring down bring the 4 on the left hand side, so we have x squared plus 7x plus 6 is equals to 0. Again, 3 methods for solving quadratic equations, either factorization, quadratic formula, or completing the square method in this case. So if we apply any of this, let's apply factorization again. 2 numbers whose product is 6 and the sum is 7. That should be 6 and 1, because 6 times 1 is 6, 6 plus 1 is 7. So I substitute these numbers with 7. So I'll have x squared plus 6x plus x plus 6 is 0. X is common, so x into x add 6, 1 into x add 6, and that should give us 0. Then take one of the brackets, x add 6, then the other side we have x add 1 equal to 0. It will imply that x is negative 6 or x is negative 1. Those are the solutions for x. And so that will give you your 3 marks. In 2001, again the question was repeated. Question was tested again 2001. In 2001, that is, we were asked to solve the equation. Solve the equation. You are asked to solve the equation. That is log x plus 24 minus 2 log 3 equal to log 9 minus 2x. Log x plus 24 minus 2 log 3 is equals to log 9 minus 2x. What you need to do, we'll take 2 to be the power of 3, and so we'll have log x plus 24 equal to, that is should be minus log 2 power 3, that's now 8, equal to log 9 minus 2x. So we have subtraction, that gives us the second law. We'll say log x plus 24 divided by 8 should be equal to log 9 minus 2x. So I will drop the logs and have x plus 24 over 8 equal to 9 minus 2x. Then we do the cross multiplication. We'll have x plus 24 is equals to 72 less 16x. Why 72? 8 times 9 is 72. And then y it's negative 16x, it's negative 2x times 8. We collect the like terms. This will be plus, so this should be 17x. And then 24 to the other side becomes minus. That should be 48. That will be 48. So we'll divide by 17. Divide by 17. That will cancel. So our x to four significant figures, that should be 2 point. So 824. That is to 4 significant figures. Again, now we have 2 or 3. 2 or 3, we have a case. You're told to solve the equation. you're told to solve log 6x minus 2 base 10 minus 1 is equals to log x less 3 base 10. So we have this case now in 203. We'll work out. First is to consider 1 and write 1 in form of log, and that is the principle that we have here. Because the base is 10, then we shall replace it with log 10, so that we have log 6x less 2 base 10 minus log 10 base 10 is equals to log x less 3 base 10. Subtraction, so we have log, that is 6x less 2, we divide by 10, log x less 3, that is base 10, again base 10. So now we drop the logs. When you drop the logs, we end up having 6x less 2 over 10 is equals to x less 3. So we do the cross multiplication. And so we have 6x less 2 equal to 10x less 30. And collect like terms. 10x to the left, it will be negative 4x. Negative 2 to the right, it will be negative 28. So you divide by negative 4, and your solution x will be positive 7. So that is the answer, and that should be 4 marks in 2003. And so you'll see the trend again. The same happens in 204. In 204 again, the question is tested, and now a bit different. Students don't like working out with fractions and decimals. They think fractions and decimals are not part of the questions or part of mathematics. And so that is what you are given in 2004. So you are asked now to solve. Again, the instruction is without using mathematical tables. Good, because now this is simplification. We are simplifying in 2004. We are told to evaluate without using tables the expression 2 log 5 base 10 minus a half log 16 base 10 plus 2 log 40 base 10. I highlighted to you that we are looking at two things. We are looking at solutions of logarithmic equations, and number 2, simplifications of logarithmic expressions. So from 1992 up to 2003, we were dealing with equations. That is what was tested. When we come to 2004, we are not doing the equations. We are now doing expressions. And so that's why there is no equal sign. An equation has an equal sign connecting the left and the right hand side, but an expression is only one term. And so that is one side of the equations. And so we look at this, applying again the laws of logarithms, because that is what we are using. 2 becomes the power of 5, and so we have log 25 base 10, a half goes to the other side. We have the square root of 16, that is log 4 base 10, plus log 40, that is we square now shall have log 1600 base 10. 1600 base 10. So we'll work out this to have log 25. We divide by 4, then we multiply by 1600. We multiply by 1600. 4 1, 4 here, this is 400. And so we have this is as log 25 times 4, that is 100. 1, 2. And remember, it's base 10. So when you have log 10,000 to base 10, so this is the same as having a log 10 power 4 base 10. So using the third law, this comes before the log. So you have 4 log 10 base 10. But we've said log 10 base 10 is 1. So the solution here is 4 by 1, which is 4. That is the way we simplify that expression. And that was 3 marks in 2004. So again, 205, what happens is we are not given the expression. We are now given an equation. So we work out the equation in 205. In 2005, we work out the equation given is, we find the value of x. So I'll summarize it as find the value of x. Find x in log x squared minus 9 base 2 equal to 3 log 2 base 2 plus 1. So the change in 205 is that we are introduced to a different base apart from base 10, because all along we've been working out logarithms to base 10. But now in 2005 onwards, now we are now given exposure to questions that are of different base apart from 10. And that is why we have the case for log of this number which are given to base 2. So again, we'll start with the right-hand side. On the right-hand side, we have 1. We have to write 1 to the log of base 2. And so we'll have this case, log x squared minus 9 base 2 is equals to 3. 3 now comes to power of 2 to have log 2 power 3, that is 8 base 2, plus now we have log 2 base 2. Log 2 base 2. Multiplication, so we have log x squared less 9 base 2 is equals to, this is log 16 base 2. Dropping the logs, we have x squared less 9 equal to 16 is equals to 16. So we take negative 9 to the right hand side, that becomes positive. So x squared is equals to 25, and x becomes the square root of 25, which is plus or minus 5. Plus or minus 5. That is 2005, and that amounted to 4 marks, as short as it is. Now, in 2006, we are given an expression. We are given an expression. We're given an expression, and we are asked to evaluate. We are told to evaluate. We are told to evaluate. We are told to evaluate 6 log base 2, then plus 10 log 243 fifth root. Then we have 2. So we start by this. The cube root of 64, that is 4. So we have 6 log 4 base 2 plus the fifth root of 243. 243 is 3 power 5. So the fifth root of 243 is 3. So we have 10 log 3 base 2. I'll take this to the other side, so we shall have plus. Because we are simplifying, let's do it the simplest way. We have 2. At this point, 4 is 2 power 2. So I'll have 6 log 2 power 2 base 2. If I have this, then it means this 2 again will become on this side. So we'll have 12 log 2 base 2. Then plus, this should be base 3. This is base 3. Correct this one. Not base 2. This is base 3. Base 3. So what you have now, this is 10 log 3 base 3. And 3 log 3 base 3 is 1. So it means 10 times 1, which is 10. Again at this point, 12 times 1, which is 12. So we have 12 plus 10, which is 22. We have, that is the answer. So in this case, what we are doing, we are simply applying the laws of logarithms, but now to simplify a logarithmic expression. That was 2006, which was 3 marks. That is 3 marks. In 2007, we missed to have this topic tested, but we find it in 2009 in paper 1 and in paper 2. And so we have one part tested for paper 1 has a concept that applies both form 2 logarithms and form 3 logarithms. And then paper 2, it is now the laws of logarithms, which is in form 3. So let's look at what was in paper 1. That is, you're told, that is 2008. We have 2 questions. The first one, you're told given that log 4 equal to 0.6021 and log 6 equals to 0.7782, you evaluate log 0.096 without using a calculator or a mathematical table. This is a very simple case. What you need simply to do is to first write 0.096 as a fraction. We'll have it as a 96 over 1,000. 96 over 1,000. If we simplify 96 over 1,000, then we'll have 24 over 250. 24 over 250. We are trying to look at possible numbers that we can write that has 4 and 6, which can be written to the given numbers. Now, if you look at 250, we'll have a problem writing 250 in terms of 4 and 6. 24, it is easier because 24 simply means 6 times 4. That is 24. If you come to 96, 96 factors of 96, this is 248, and then we have, at this point we can have 6, 8, then 2, 4. So that I have 2, this is 4, 3 times 6. In fact, that is what will work out so well. 4 cubed by 6. 4 cubed, that is Is it 4 cubed? 4 squared. 4 squared, that is 16 by 6, which is 96. So I will replace it here and then have log 96 over 1000. This one simply means log 96 minus log 1000. But 96 is 4 squared by 6. So it will be log 4 squared times 6, then minus log 1000. Already given log 4 as 0.621. So this means now I have log 4 squared plus log 6 minus log 1000. And this is 2 times. Now log 4 given as 0.6021 plus log 6 given as 0.7782. Log 1000 is 10, is 3. Log 1000 is 3 because that is 10 power 3. So what will work out this one, 2 by 0.6021, that is 24021 plus 0.7782 minus 3. If we work out this one, we have that is 4, that is 12, 1.982 minus 3, one point 0.76. 0.176. So that becomes our working for that. Now you can try as many questions from 2008 onwards and see what was happening. You'll find again in 2010 there were 2 questions, paper 1 and paper 2. In fact, 2010 there were 3 questions. Each one of them requires the application of the laws of logarithms. We missed 2011, we missed 2012, but we got the question in 2013. 2014 we missed, we got in 2015, and so on up to 2019. So other questions you can try them on your own as you revise mathematics. In 2001 we had log. For 2001, this is what we said. The question is we solve the equation. Solve the equation. That is log x plus 24 minus 2 log 3 is equals to log 9 minus 2x. Log 9 minus 2x. So we'll start. Again, this is what we say. We have log x plus 24 minus, this to this side becomes now log 3 power 2, that is 9, equal to log 9 minus 2x. Division, so we have log x plus 24 over 9 is equals to log 9 minus 2x. Then we drop the logs, so we'll have x plus 24 over 9 is equals to 9 minus 2x over 1. Then we cross multiply, so you have x plus 24 is equals to 81 less 18x. Then we collect the like terms, minus 18 to this side becomes positive, so that is 19x. 24 to this side, 81 minus 24, That is 57. To get x to divide by 19, divide by 19. So this cancels, and our x should be equal to 3. That is the value for 2001 question. Okay, with that now, I think we can come to the the end of our lesson today, and hoping to meet you next time again to look at more of questions on further logarithms and any other topic that we may have to discuss. From me, I've been your teacher, Mr. Ndenga Elfas. I wish you a nice day and ensure you keep safe. Thank you.
Individually, I had realized that, okay, I'm good at, speaking, I'm good at this and that, and then I figured out, so how